$500 versus GPT-4. It sounds like an unfair fight, but when we put them head-to-head on a real production task, the tiny, fine-tuned open-source model didn't just compete, it crushed the giant. For anyone building AI solutions, the common belief is that bigger equals better. But in enterprise applications where latency and cost scale linearly with usage, generalized intelligence is often the most expensive bottleneck. Our goal was simple: to achieve a specific business review task performance that matched or exceeded GPT-4's output, but without the prohibitive API costs and the unpredictable latency spikes. So we moved beyond the generalists. We chose a small, highly efficient model, a Llama variant, and treated it not as a black box, but as a foundation waiting to be molded by our proprietary data. The secret sauce wasn't the model itself, it was the data. We spent weeks curating, cleaning, and formatting our proprietary business reviews, thousands of examples mapping inputs to the exact desired outputs. This wasn't just data dumping. It was targeted instruction. We used these examples to teach the small model the unique jargon, the specific organizational context, and the subtle nuances of our business domain. Then came the fine-tuning. We didn't retrain the whole behemoth. We used efficient techniques like LoRA, surgically injecting our domain knowledge into the model's weights with minimal computational cost. This low-rank adaptation allowed us to achieve expert-level domain performance in a fraction of the time and computational resources it would have taken to compete head-on with GPT-4 scale. When we ran the benchmarks, the real-world production tasks, the difference wasn't theoretical. The small model didn't just answer, it answered our way matching our internal experts' quality. The cost comparison was stark. The generalized model incurred significant variable costs simply trying to generalize, whereas our dedicated model ran on a fixed, predictable compute budget. The ultimate win was predictability. We replaced the variable black box cost of an API call with a deployable, owned asset, a machine learning model running on our infrastructure. So the lesson isn't that scaling is bad. It's that smart scaling means achieving sufficiency. For niche, high-volume tasks, deep tailoring beats brute force generality every single time. If your application is defined by domain expertise and specific constraints, don't reach for the biggest model. Reach for the most focused one.